Hello everyone. I've decided to make a lecture video on section 4.1 where we left off with the introduction in class. So I am going to begin today on page 30, I think it's page 36 of your note packet for Module 2, Exam 2. And before we start covering that on page 36, I just want to point out that it's more of what we talked about on page 2 of the supplemental handout that I gave in class. I have it up here on the whiteboard. On page 2 of your supplemental handout, right, I gave you the graph of this arbitrary function. It's just a polynomial. And we noted that, reading the graph from left to right, starting here, from here down to this point here, the slope of the graph is negative. We're going downhill, and the values of the function are decreasing. So we say f of x is decreasing on that interval. And then from this point here to this point here, we're going uphill. The slope is positive, and the function values are increasing, and so we say f of x is increasing. And then from this point here to the right, we're going downhill. The slope is negative, the values of the function are decreasing, and we say f of x is decreasing. At this point right here, right, it's like the bottom of a hill, bottom of a valley, where we go from negative slope to positive slope. That forms what we call a relative minimum. We're at the bottom of the hill. And over here at this point where the slope goes from positive to negative, we're at the top of a hill. And that is what is called a relative maximum, okay? So this is what we covered in class, right? The supplemental material we covered in class. Page 36 of your packet, right, is a continuation of this discussion. So we'll go to page 36 in your packet now. And so you're given two graphs on page 36. And we're going to do the same thing with these graphs that we did with the supplemental handout. So again, this is a graph of a polynomial. We're reading the graph from left to right. You can see from this point down here to this point up here, okay? The slope at each point on the graph is positive. We're going uphill, and so the function f of x, we say, is increasing, okay? From this point here to this point here, we're going downhill, okay? The slope is negative, and we say the values of the function are decreasing, right? So we say f of x is decreasing. And then from this point here to the right, we're going uphill, right? The slope is positive. The values of the function are increasing, and so we say f of x is increasing. Okay? So right here, at this point right here, we're at the top of a hill, right? Slope goes from positive on the left to negative on the right, and that forms what we call a relative maximum. And at this point right here, okay, the slope goes from negative to the left of that point to positive to the right of that point, right? We're at the bottom of a hill, and that forms what we call a relative minimum. Okay? So we can put this in words, okay? If the slope goes from positive to negative, okay? that yields a relative maximum. Okay? And we can also say that if the slope goes from negative to positive, right, around a point, that yields a relative minimum. Okay? That's important, okay? In determining, given a function, right, determining where the relative minimums and the relative maximums are, right? So if slope around a point goes from positive to negative, we know that's going to create a relative maximum. If the slope goes from negative to positive around a point, okay, that's going to create a relative minimum. Now let's look at the next graph. And again, looking at the graph from left to right, starting here, you can see from going from here down to this point, the slope is negative. And so the values of the function, right, we're going downhill, so values of the function are decreasing. So we say f of x is decreasing. From this point to this point, we're still going downhill, okay? So the slope is negative, and the values of the function are decreasing, continuing to decrease. Okay. And then to the right of this point, right, we're going uphill, slope is positive, and values of the function are increasing, so we say f of x is increasing. Okay. Well, so here we're at the bottom of a hill, right? Slope went from negative to positive, so that's a relative minimum. But at this point right here, okay, the slope is not negative and it's not positive, right? The slope is equal to 0. So it's like a little flat plateau here coming down this hill. If we're with this side of the hill, we were walking down it. When we got down to this point here, we'd be on a flat surface momentarily, and then we would continue to walk downhill. So when we went from negative slope to the left to negative slope on the right, that did not produce a minimum or a maximum, okay? It just produced a flat spot in the graph of this function, okay? So going from minus to minus, going from negative slope to negative slope doesn't yield relative maximum or a minimum. Okay? There has to be a change in the sign of the slope from one side to the other. And we know from over here, okay, slope going from negative to positive yields the relative minimum. Okay? So given a function f of x, okay, using the test point method, we can find the points in the graph of that function where there's relative minimums and where there's relative maximums, and for what values of x the function is increasing and what for values of x the function is decreasing. Okay? And so that's what we'll do on the next page. For the functions that follow, we're going to determine where the relative maximums and relative minimums are at, where the function's increasing and where it's decreasing. At the bottom of your rectangle on page 37, it says, let's go back to f of x equals x cubed, okay? and determine the relative extrema. So we looked at this on your on your supplemental handout, okay? And when we did the test point method for the first derivative, f prime of x, right? X equals 0 was a critical number, right? X equals 0 made the first derivative, or f prime of x equal to 0. And when we did the test point method to see what intervals a function was increasing or decreasing, right? We had to do a test point method with the first derivative. We found that the slope was positive for values of x less than 0, and the slope was positive for values of x greater than 0. Right? The function was increasing on both those intervals. So there's no relative maximum or relative minimum. When it talks about relative extrema, it's talking about is there a relative maximum or is there a relative minimum. Okay? So there were no relative extrema because, in a nutshell, there are none because of no sign change in the test point method on the slope. And I drew you the graph of this function by hand, and if you remember, it looked like this. It's going uphill from left to right, but at this one point at x equals 0, there's a flat spot in the graph where the slope is equal to 0. Okay? So it's going f of x, the function's increasing for values of x less than 0, and it's increasing for values of x greater than 0. All right, in example 1, you're given this function f of x, and you have to find the critical numbers and the relative extrema, right? Where in the graph of this function are there relative maximums and where are there relative minimums, okay? And determine where the function is increasing and decreasing. And so you got some blanks at the bottom of the page that you have to fill out. So pull those up. So our function is f of x is equal to x cubed minus 3x squared minus 24x plus 92. So to find the critical numbers, we have to differentiate the function and set it equal to 0. So f prime of x, right? This is a polynomial of degree 3. Use the sum and difference rule, differentiate term by term. Derivative x cubed is 3x squared. Derivative minus 3x squared is minus 6x. Derivative minus 24x is minus 24. And you know, derivative of a constant, 92, is equal to 0. Now to find the critical numbers, we set this derivative equal to 0 and solve for x. So we have 3x squared minus 6x minus 24 is equal to 0. And you should recognize this is a quadratic in one variable. And so you can use the quadratic formula or factoring to find the values of x. Well, this thing actually factors, okay? 3, minus 6, and minus 24 are all divisible by 3. So we can pull out a 3. And we have 3 times the quantity x squared minus 2x minus 8. Okay? Verify that by distributing the 3. Well, this x squared minus 2x minus 8 factors in the traditional sense. It factors into x minus 4 times x plus 2. So now we have the product of 3 quantities, right? 3 is a quantity, x minus 4 is a quantity, x plus 2 is a quantity. And if you have a product of 2 or more quantities is equal to 0, then by the zero product property, one of those quantities has to equal 0, okay? Well, 3 can equal 0 because it's equal to 3, but the second quantity, x minus 4, can equal 0, and the third quantity, x plus 2, can equal 0. And when you solve for x in these two equations, you get x is equal to 4 and x is equal to minus 2. So x equals 4 and x equals minus 2 are the critical numbers. Okay? So we can write those down here at the bottom in the blank, minus 2 comma 4. Right, those are the two values of x that make the first derivative equal to 0. Okay? F prime of x equal to 0. Now, to find the inner values of x where the slope is positive and where it's negative, we do a test point method. So we're going to take the real number line, it's polynomials, the domain of any polynomials, all real numbers, and our test point method is going to be applied to the f prime of x. And we use the two critical numbers to split up the real number line into intervals. So here's minus 2, and here's 4 on the real number line. And so we have 3 intervals, okay? And for each of these intervals, we're going to do a test point to see if the slope is positive or negative. And if it's positive, slope is positive for one number in the interval, it's positive for all numbers in the interval, okay? If it's negative for one number in the interval, it's negative for all numbers in the interval. So our first interval, right, is for values of x less than minus 2, right, between minus infinity and minus 2 on the real number line. So in the first column, right, I'm going to create a little table here. First column is labeled test point, and the second column is labeled f prime of x. I'll give myself a little more room over here. So, in this first interval for values of x less than minus 2, I'm going to use minus 3 as my test point. Okay? And when I put in, now you can use, when you plug in for x, you can use the quadratic, 3x squared minus 2x minus 24, or you can use the factored form down here, right? This up here is equal to 3 times x minus 4 times x plus 2. Well, if I put in minus 3 for x down here, I have 3 times minus 7 times minus 1, which is equal to 21. That's positive. So that says for any value of x between minus infinity and minus 2, the slope is positive in the graph of this function. And so f of x is increasing for any value of x less than minus 2 in this function. In the second interval from minus 2 to 4, I'm going to use 0 as my test point. 0 usually is a good choice. And when I put in 0 in for x, I have 3 times minus 4 times 2, which is equal to minus 24. That's negative. So the slope for this function is negative for all values of x between -2 and 4, which means the function is decreasing for all values of x between -2 and 4. And then lastly, we have the interval from 4 to infinity, right? Values of x greater than 4. So I use 5 as my test point. And I plug in 5 for x here in factored form, right? And this is f prime of x. In factored form, I have 3 times 1 times 7, which is equal to 21. So the slope is positive for all values of x greater than 4, which means the function is increasing for all values of x greater than 4, okay? So down here at the bottom of the page, where you gotta give the intervals where it's increasing, where it's decreasing, you can see that it's increasing from -infinity to -2 and from 4 to infinity. Slope of this function is positive for all those values of x, okay? Where is it decreasing? On the interval from -2 to 4. For those values of x between -2 and 4, right, the slope is negative and the function is decreasing. Okay. And now you're asked to find the relative maximum point. Remember, it's asking for the maximum point. That's an ordered pair in the coordinate plane. It has an x coordinate and it has a y coordinate. Same thing over here with the minimum point, relative minimum point. It has an x coordinate and a y coordinate. Well, up here at x equals -2, we go from positive slope to negative slope. We know that that forms a relative maximum. So the x coordinate for a relative maximum is -2. How do we get the y coordinate? We got to plug in -2 in for x into the original function. Okay? And remember, y values and function values are the same. So when I put in -2 in for x into the original function, it'll give me the y coordinate of where that relative maximum is located. Well, f of -2, I'm not going to write out all the gory math, but if you put in -2 in for x up here on the right-hand side and then follow the order of operations, you get f of -2 is equal to 120. That's the y coordinate where this relative maximum is located. So the relative maximum point has an x coordinate of -2 and a y coordinate of 120. Now the relative minimum point. Okay. Well, at x equals 4, right, the slope is negative to the left and positive to the right, right? We go from decreasing to increasing. That forms a relative minimum at x equals 4. So the x coordinate for the relative minimum point in the graph of this function is 4. How do we get the y coordinate? We plug in 4 in for x and f of x up here and calculate the value of the function at x equals 4. That gives us the y coordinate. When I do that, I get f of 4 is equal to 12. So the point in the coordinate plane where the relative minimum point is located has coordinates, x coordinate of 4 and a y coordinate of 12, okay? Now I need to give you a caveat at this stage, right? A warning, okay? You notice that the notation for the relative minimum point and the notation for the interval where the function is decreasing is the same. So just as in the English language, the meaning of a word depends upon the context in which it's used, Well, in mathematics, right, there's a lot of notation whose meaning depends upon the context that's being used. The notation is the same for these two guys. But for the relative minimum point, the first number is the x-coordinate and the second number is the y-coordinate. That is what we call an ordered pair. Okay? Where the function is decreasing, that is an interval of numbers. These are the values of x where the function is decreasing. And we're saying that the function is decreasing for x greater than -2 and less than +4. So this is an interval of numbers. So you got to be very careful, ladies and gentlemen, okay? What notation means depends upon the context in which it's being used. The notation is the same for these two guys. One is an ordered pair and one is an interval of numbers, okay? So you got to be careful. Okay? So I hope all this helps, okay?